Hello, grade 10s. Today we will be talking about ecosystem dynamics. So, competition occurs when two or more organisms compete for the same resource, such as food, in the same location at the same time. So, here is an example. We have a lynx and we have a bobcat who compete for the same food source and live in the same environments. Predation occurs when one organism, the predator, consumes another organism, the prey, for food. Symbiosis, the interaction between members of two different species that live together in close association. So there are three types of symbiotic relationships. There's mutualism, commensalism, and parasitism. So mutualism is where both species benefit in some way from their relationship. So here we have an alligator with the Egyptian plover. So the alligator, after they eat their meal, the Egyptian plover comes in and it actually cleans the alligator's teeth, and it allows that. And so the plover gets a meal, and the alligator also benefits because it gets its teeth cleaned. Then we have commensalism, which is where one species benefits and the other species, nothing happens, like nothing negative or positive happens to it. So, for example, here we have a rhino, and then we have some birds living on its back. So the birds get protection from predators, and they also eat the little bugs that fly around the rhinos, but the birds, they don't harm the rhino, and the rhino kind of just lets it happen but doesn't benefit. And then finally, we have parasitism, which is where one species benefits and the other species is negatively effective. So we have everybody's favorite species, the tick, which is a great example of that. So now we're going to talk about population ecology a bit. So exponential growth. Accelerating growth that produces a J-shaped graph when the population is graphed against time. This is not sustainable and does not usually happen in the wild. So for example, here is the human population graphed. So as you can see, it starts out here and the growth rate was pretty stable, and then boom, we had exponential growth happen around here, around 1800, with the Industrial Revolution and increased efficiency in technologies and medicine and things like that. And we've just been growing since then. However, exponential growth isn't sustainable in the wild because, unfortunately, ecosystems cannot support that. So, and that's because of limiting factors. So, limiting factors, or a limiting factor, is a factor that limits the growth, distribution, or amount of a population in an ecosystem. And there are two types of limiting factors. There are density independent and density dependent factors. So first we're going to talk about density independent factors. So that includes any factor in the environment that does not depend on the number of members in the population. So this usually includes abiotic phenomenon and factors that happen either by humans or naturally. So that includes weather events, flood, droughts, fire, cold snaps, heat waves, things like that, and pollution as a result of human activities. So you can think of it like this. So I'm sorry, grade 10s, I know I would talk about fish a lot, but so let's pretend we have fish in the water. So because we're talking about pollution, that would be a density independent factor. And you can think of it because it wouldn't make a difference if there was one fish in the water or if there were many fish in the water, the fish would still be negatively affected, regardless of the number of fish in the water because of the pollution. And same with fire, too. So if you had a forest or whatever, it wouldn't matter if there was one deer or if there were 1,000. The outcome would still be the same. So density dependent factors, any factors in an environment that depends on the number of members in a population. So this usually includes biotic factors like disease, parasites, predation, and competition. So things like diseases spread much quicker if there is a large population. And you can also think of the number of species also affecting the amount of food that's in that's available in a population. So if there isn't enough food, that's usually because there are too many members of a species in an area. So that is a density dependent limiting factor. So carrying capacity. In nature, limiting factors prevent indefinite exponential growth. Growth slows and the population levels off. The point where the population stabilizes is the carrying capacity of an ecosystem. So you can see here, we have exponential growth, and it just keeps growing and growing and growing. But like as we talked about with density independent and dependent factors, it would have to stop at some point and level off. So this is what happens in nature, where you start off and then the number of species grows at a stable rate, and then boom, something happens, and then all of a sudden the population grows. But then because of limiting factors, it eventually stables off. And the point, sometimes there could be a bit of a fluctuation too, but the average where the population stabilizes is the carrying capacity. The carrying capacity is the size of a population that can be supported indefinitely by the available resources of an ecosystem. So you can see here, this bowl realistically would be way too small for these 3 goldfish, but bear with me. Obviously, this is not the proper carrying capacity here, but you can see these fish in this diagram at least seem to be healthy. So you can assume that the carrying capacity of this bowl is 3 goldfish. And tomorrow we will talk more about graphing population graphs and figuring out the carrying capacity of an ecosystem. Just another example about fluctuation. So just because there's a top, that does not mean a top of your graph, that does not mean that that is the carrying capacity. It is where the graph averages out when you graph the population versus time. So for example, we'll just talk about deer. So in this winter, we have the breeding stock, and then a bunch of babies are born, and then the population booms. But then over the summer and the fall, the population goes back down because of starvation, disease, accidents, weather, hunting, predators, and other factors. And then you have the survivors that survive into winter. And so that is where the population stabilizes. So the carrying capacity for deer is realistically the number that survive into the winter. So next we're going to talk about ecological niche, which is the total sum of an organism's use of abiotic and biotic resources in an ecosystem. And so that can be further looked at, divided into 3 different concepts. So there's the fundamental niche, which is the full range of conditions and resources used by a species to survive and reproduce. Competition restricts a species to a portion of its fundamental niche. So for example, we'll just take one of these birds. So the Blackburnian warbler, for example, its fundamental niche is hypothetically the whole tree. So if there were no other species of bird here, this warbler could in fact, its fundamental niche is in fact the whole tree. And it could potentially live and use resources in the whole tree. But because of competition, it's restricted. So the realized niche is the portion of the fundamental niche a species actually exploits as a result of competition. So this Blackburnian warbler, because of competition, it's only accessing and using this area. So this area here is its realized niche. So it has adapted to only live and use resources in that portion of the tree, compared to the whole tree being its fundamental niche. And then finally, we have niche overlap, which is when 2 or more species use a portion of the same resource simultaneously. So you can see here there's kind of this area in here where everybody's kind of using all of the resources a little bit, but they each have their own area that's just for them, which is their realized niche. But the niche overlap is where species are using the same resource simultaneously. So again, just to reiterate, fundamental niche, whole tree. Realized niche, this upper portion of the niche. Niche overlap, where all of the birds are competing for the same resources. So specialist versus generalist species. So there are 2 types of extreme when it comes to talking about ecological niche. There are specialist species, which live in a narrow niche. They are less adaptable because of specialized needs. They are more likely to become extinct. They are very sensitive to changes in their environment and to their food source, things like that, because they occupy a narrow niche. And they have the advantage when conditions are stable. So specialist species include this cute little koala over here in the corner, who's a specialist because koalas only eat, if I remember correctly, eucalyptus trees. They only live and eat eucalyptus leaves. So yeah, their niche is very small, and they will not survive if there aren't eucalyptus trees present. Same with this little panda here. So also very sensitive to change, only eats bamboo, only lives in bamboo forests in China. Yeah, but if conditions are stable and their niche is fulfilled, they will both thrive in their environment. But unfortunately, because of humans and things like other factors, obviously the panda is endangered and the koala also isn't doing very good right now. Anyways, there are also generalist species, which operate out of a broad niche. They are adaptable to many habitats. They have a high range of tolerance. They're less likely to become extinct, and they have the advantage when conditions are unstable. So you can think of like a raccoon. A raccoon will eat basically anything, including garbage, and they'll live in a wide variety of habitats, and they're able to adapt very easily. So that's it for today for new information, and you can find a worksheet on limiting factors on Edsby. Please submit the worksheet when you are done. Thank you, grade 10s.